Okay, so you guys are CSUC. You just heard all this stuff. What do you think is the biggest threat? The biggest real threat? If you were actually in Congress and had to argue for one of these threats being the most real, which one would you say? And you can't argue for your own damn threat from your own team. You gotta be unbiased. And by the way, nobody in CSUC knows any physics. So they don't know about the Tacoma Narrows Bridge falling down in 1933 due to a resonance phenomenon. Although they've probably seen the movie. So, yes.
I would say drought.
You'd say drought. Why?
Because I think it's something that would affect all of these put
Okay.
together. Because if we're in a drought, then we don't have water resources.
Yeah, you spelled drought. That's pretty good.
You need water resources to fight fires. You need them in disasters to do that kind of stuff. So it's a like a more base disaster.
So you think drought has the largest connected implications?
Mm-hmm.
Okay. That would be the last one I would pick, by the way, but that's okay. I'm not involved in any of this and I don't know anything.
I think I would probably say hurricane.
Okay. Why?
I just think it's, in terms of just politically, like, it's the things that have gotten the most attention and the things that, like, most drastically, impact constituent lives.
Actually, I completely disagree with that, too. So, Superstorm Sandy, which I'm not sure, I think your statistic of 120,000 people without power after 2 weeks, I think that's completely wrong. I think there were several million people. There were 60 million people without power at peak. 2 weeks later, there were still several million. 60 million people didn't have power for at least about a week after Superstorm Sandy. We have done nothing to change that strategy. That should have been one of the biggest wake-up calls to our unpreparedness on a national level there was. And we haven't done shit. In the same way, New Orleans is not any safer now than it was in 2005. So, in principle, you might be right. In practice, we're not really doing anything.
Well, what I meant was it's the worst one that we haven't done anything about.
What defines worse?
Well, wasn't the question which one is the worst one that you would
Which one is the most real threat?
Oh, okay.
That was the question. It's the most, that one's the most infrequent one, too. Yeah.
I would have said drought, but since you said that was a bad idea, I'm going to guess fires. Because
No, I didn't say it was a bad idea. I said, I don't believe it, and I'll tell you why momentarily. I don't think it's the most, well, whatever.
I would guess drought or fire just because it's most in Congress's mind.
What's the difference between droughts and fires in terms of management on large scales?
I feel like drought is more like long-term.
Right, thank you. Somebody even used that big word in their presentation, which I can't spell, nonlinear. CSUC can't even deal with linear problems, okay? Right? So this wildfire problem, to me, is clearly the biggest threat because it gets nonlinear real fast. We have no resources devoted to this whatsoever. A drought is something that happens slow. It gives you time to adjust. Doesn't mean you will, but it gives you opportunity space. I mean, the Yellowstone fire is a perfect example of this. What was the policy? Oh, let's just wait till it starts snowing. Because we can't put it out. We can't solve that problem. So by nature, it's the wildfire thing that's the biggest threat because we've already proven incapable of solving that problem. Obviously, on a longer time scale, drought's the biggest worry on a long time scale. But you know, on the annual time scale, it's definitely fires. So this sort of leads to the next question: which of these is actually solvable? CSUC wants to invest in solutions that will work so they can get reelected. So which one of these things do you just sort of stand back and say, fuck it, right? Because that's always a solution. Actually, this video is going on YouTube later. Whatever, it's part of class. And which solutions should we invest in because they're actually working and will look good? So which one of these threats really lend themselves to solutions, do you think? And again, to me, there's actually one obvious one that leads itself to solutions. But I don't know anything, and you guys are been elected, so. What do you want to put your money into? What problem do you want to solve to look good? And CNN can lavish praise on the effectiveness of the U.S. Congress for responding to a large-scale disaster.
Okay, my guess would be polar vortex. You just can basically buy some or retrofit some pipes and.
Well, it's a little bit more than that. Okay, so he votes for polar vortex. Any other candidates here? Why? Keep going.
Well,
They don't want to say anything.
I mean, it's like the solution sounded easy enough where you can say, "Hey, we got these pipes fixed. Hey, we got new snow plows," and then the citizens are going to see, "Hey, my pipes aren't bursting." Hey,
Okay,
snow
so the
plows
solutions are more practical
Yeah.
to obtain,
Mhm.
right?
It's easy for citizens to see that they're doing something.
Yeah.
Well, and it could, you kind of have a little bit of warning for the polar vortex as well.
Okay, a little bit, yeah.
Like more than a wildfire or drought
Right.
in some ways.
Well, I don't know about drought. I mean, wildfires for sure.
Mhm.
There's a real important difference between the polar vortex scenario and the other three. Okay, what is that? There's a current thing happening right now. There's a polar vortex happening right now.
The planes, the
What?
transportation.
Well, yeah, the transportation goes away, but you don't really need to fly anywhere. It's okay. But what can you do in a polar vortex that you can't really do in the other ones?
Stay in your house.
You can stay in your house, right? You're not going to stay in your house at a, what's that thing called, the Urban Wildfire Interface? Well, you're not going to stay in that house, right? You're probably not going to stay in your house in a Superstorm Sandy situation because your house might get destroyed, right? If you don't have any fresh water due to city drought, you can't stay in your house. But a polar vortex is something that doesn't last forever. It lasts maybe 5 or 6 days at worst. You could stay in your house and ride it out. And essentially there's no aftermath to a polar vortex if you have the right snow removal equipment. Right now the city of Boston has run out of places to dump snow. They're no longer removing it. The only place they can put it is in the ocean. And that's energy intensive and the like. So a polar vortex is something that's solvable during the actual event. We could do better, but then requires a better long-term strategy and recognition that you're going to get one next year and one next year and one next year, which means the airline industry needs to learn from this, and that's the last industry to learn anything. Yeah.
Are the polar vortexes connected to climate change, or?
Yeah, when we talk about climate change, we'll talk about this very briefly. Climate change is about one thing and one thing only in terms of its operations, and that is seasonal jet stream patterns change. That's what climate change is. Okay, that produces weather volatility and all kinds of stuff. And so a polar vortex is normally never goes very far south, never goes south of the U.S.-Canadian border because the jet stream always entrains it. In the summer of 2013, it took you a long time to fly from the west coast to the east coast that summer because the summertime jet stream was the weakest it's ever been in history. It took about 40 minutes longer to fly from Seattle to New York than normally. It was so weak because the weather goes from west to east, that there was a long-term low pressure system that went backwards for 3.5 weeks from east to west across the country. That's never happened before. Okay, the polar vortexes are happening because the jet stream patterns are changing. This is what climate change is. As we heat the oceans, we alter all of that. We'll talk about that later when we talk a little bit more about climate change in some detail. Hurricane strength is not responding to climate change. This is a myth. It's a myth that can be shown scientifically. There's a good honors college thesis written on this in 2009, and we're still working on publishing that because I wanted to wait a few more years to get more data. The frequency of hurricanes is definitely not increasing. Hurricanes frequency, this is just for the Atlantic. Situation in the Pacific is much different. In the Atlantic, hurricane frequencies are decadal. There's 20 years of high activity, and then there's 20 years of no activity or little low activity, and 20 years of high activity. So we're not seeing an increase in frequency of hurricanes. However, what we are seeing are higher probabilities of Cat 3 and Cat 4 storms per hurricane season than we've ever seen in the past. And this is well proven scientifically. And we'll talk a little bit about that later. The last thing I wanted to talk about, and I'm glad that you guys, the wildfires, mentioned it, there is a great deal that can be done with sensor nets. This idea that we can use drones for real-time monitoring of conditions in the Earth's pixels is a very, very big deal. I'll give you an example of a proposal that I sent to Google a couple of years ago in their Let's Do Something Big in the World deal. They haven't done anything with on anybody's proposal. But the basic idea was this, and it's related to drought and rainwater collection, which we could now actually adapt this model to California. Let me give you the two examples that I put in this paper. The first is Kansas. Kansas looks just like this, which is why you can do this in Kansas. And in Kansas, you put in a sensor, density of about 1 sensor per square kilometer in Kansas. So this is 100,000 sensors. Okay? That's not a problem. That's easy to do. And then you have a dedicated satellite. Suppose it looks like that. And this stuff is sent up to that satellite. That requires some transmission power, but it's not prohibitive. You can do that with solar-powered batteries and stuff like that. And then this gets beamed back through a very big pipe back to the Earth. And Google has launched such a satellite network in January 2013. And what this means is that the average citizen in Kansas, then they have a device with them, a network device or whatever. And this is for tornado warnings. The average tornado warning in the U.S. is 26 minutes. Hundreds of people are killed a year because it's 26 minutes. I'm sorry, other way around. The average tornado warning time is about 13 minutes, sorry. The proposal was to double that, and that will save many thousands of lives. Okay, so each one of these sensors is a tornado sensor. Not that an actual tornado exists, because if an actual tornado exists over the sensor's probably not there anymore. But that the conditions, the local atmospheric conditions, have high probability of spawning a tornado. And so at any given time, a citizen can load this tornado map on their device or project it on the wall or see it at Walmart or whatever. And you'll see this big gigantic red area in that part of Kansas. This is happening in real time right now. It's not a watch, it's not a warning, it's happening right now. People will respond to that. The other example is Kenya. I'll keep the K. Kenya. Kenya doesn't look like Kansas, it's actually oriented the other way, but whatever. And this is related to drought, in African drought, which is quite severe. And so here in Kenya, we're gonna put these rain sensors everywhere. Because the worst thing that can happen in Kenya is when a cloudburst happens or an isolated thunderstorm starts to rain, all that rain just falls on the desert and drains into nothingness right away, okay? So as soon as one of these sensors lights up that it's raining, then this big rain collection truck, hydrogen powered if you want, solar powered if you want. We have a whole fleet of these vehicles that are located all around Kenya, which can reach one of these sensors in 5 minutes. Because the rain event's only going to be an hour long or so. And so when these things goes off, the truck gets immediately dispatched there, opens up and collects all that rain. Because else the rain doesn't get to the people or the crops. And you have to respond in real time. So the potential of these real-time sensor nets for environmental monitoring has a very large capacity for humans and institutions and civilization to finally be proactive. Because we can monitor what's happening in real time and we build response networks that happen in real time. One already knows this works. You're all part of a flash mob experiment. Okay? It's the same principle. You're going to react in real time to some information, and your reaction in real time is going to change the conditions, which is going to then change the conditions again. You already live in that world where you're used to reacting in real time because you're getting pixel-based, location-based information in real time. And this is just to get more and more ubiquitous, and we might as well start turning that technology toward fairly useful things like saving people's lives, because it's possible to do that. And that's sort of the big picture here. So in terms of these 4 events, yes, the polar vortexes are happening. Their major impacts are economic because people don't go shopping, but once they get south of the Mason-Dixon line, so to speak, that's where the real impact is, as we saw in Atlanta, Georgia in January 2014. There's no infrastructure for removing snow in the south because it don't snow in the south. The drought situation is extremely serious over longer timescales, and we have no strategy for dealing this with long timescales. Where is our strategic drought reserve? We have a strategic petroleum reserve, but we can't drink petroleum. We have no strategic water reserve other than these natural reservoirs like Lake Tahoe or the Great Lakes or something like that. And nobody wants to drink water from the Great Lakes because it's full of all kinds of stuff. So this is a serious problem that we're not prepared for at all. If this 35-year drought scenario came into play, we might as well just be the Mayans. I mean, just punt. We can't deal with that. We'd have to learn how to do actual fusion as an energy source to desalinate the oceans. So that's a real problem. The wildfire is an annual thing. That's not something that's continual. It's usually a summertime problem. Although it's in Florida and South Carolina and California, it's starting up earlier and earlier in the spring. That's mostly a budget and resources issue, mostly. Hire more firefighters, build more planes, develop better drone firefighting technology. I mean, why can't you just fill up a Predator drone with 1,000 gallons of water and send it to the fire? I mean, you could do this, right? There are lots of things that we can do to better deal with fires. Also, sensor nets help. We should start putting sensor nets all over forests. So in these isolated places, when a fire goes off, we'll actually know. Yeah, fire went off in grid 17-3. That's in a remote location. We can aim the drone at it, okay, because 1,000 gallons of water will put that fire out. We don't even need any humans involved in this. This can just be automated. Just do it. And so what if you waste a couple of drones on a false alarm? Big deal. All you did was dump some water in a forest, and you got drone parts scattered around, but that's okay. So that's a really good example that you can do things. But the Superstorm Sandy stuff, that's the fuck it scenario. There's really nothing we can do about, if 3 or 4 of those things are lined up to hit the US over a period of 4 or 5 months, you're just screwed. You can't do anything except move 1,000 miles away or something like that. There's a scale of nature which no humans can mitigate, period. And it's an interesting dynamic as we add energy to the system. We're starting to put the system into that dynamic. So stay tuned to see what happens. So I'm done here.